Hello kids, I'm Chavi Bansal. Hope you already know me. Today we are going to talk about certain concepts of mole. We have already talked about certain mole concepts, but today we are going to apply them on few questions, and then we are going to see how the mole concept is applied on a chemical reaction. Okay, let me share my screen. Hope you guys are able to see my screen, right? So basically what we have done, we have found out overall, whatever we have studied so far, we have found out there are three ways of finding the number of moles. So number of moles can be equal to gram given by molar mass, right? This is one way of finding out. Second is number of entities divided by Avogadro's number, which is 6.022 into 10 raised to power 23 entities, right? This will also give us what? Number of moles. Next is volume of gas at STP divided by 22.7 liters at STP, right? Now you will think in the previous videos, I have talked about 22.4 liters and now I am talking about 22.7 liters. So STP is standard temperature pressure, right? So if it is 1 bar and 0 degrees Celsius, then it is 22.7 liters. But if it is 1 atmosphere and 0 degrees Celsius, it is 22.4 liters. So if the question is from the previous year question papers, the like last year, very old paper, then you have to use 22.4 liters. Otherwise, in the updated ones, the latest one is 22.7 liters, where 1 bar and 0 degrees Celsius is considered as a standard standard temperature and pressure conditions. Okay. Now, these are the three ways of finding out the number of moles. Clear? We have already done it. We have already done questions on it. Let's do a last year question that is also based on of something like this, which is JEE 2023 question. Okay. What is given? There are two lists given, list A and list B, list 1 and list 2, and we have to match the things from list 1 to list 2. Okay. Let's see this. 16 gram of CH4. So can I find out the mole? If CH4 is given, it will not be equal to weight, right? Electrons will see later. Again, it will not be equal to weight, right? Either it is the volume or it is the number of electrons, fine? So the best way of doing it, finding out the number of moles. So number of moles of CH4, how much would be? 16 gram is given. Carbon is 12 plus 4, 16 only. So 1 mole, we have 1 mole of CH4, right? And 1 mole does not occupy this much volume, right? So exactly for the first one, 60.2 into 10 raised to 23 electrons. I'll prove it also. Now we have 1 mole of CH4, right? 1 mole of CH4 will have 6.022 into 10 raised to 23 atoms. Sorry, molecules of CH4, right? Now, how many electrons are present in one molecule of CH4? Carbon has 6 electrons. Hydrogen has 4 electrons, right? So total 10 electrons. So if one molecule has 10 electrons, then 6.022 into 10 raised by 23 will have 60.2 into 10 raised by 23 electrons. Okay. So for A, let me write down here. For A, it's 2. Fine. This is the easiest way. Next is 1 gram of H2O. Let me change the color of pen. 1 gram of H2. H2 ka 1 gram. So already gram is given. So again, these two options are cancelled out. Now the only option that is left is volume. So obviously for the second option, it will be 11.4 liter. But let's see. Fine. So again, the best way is to find the moles. Now, moles of H2. H2 is 1 gram given. And what is the molecular weight? 2. So 0.5 moles are present, right? Next, we are given with volume. Now, we know 1 mole occupies 22.7 liter. So 0.5 will occupy 0.5 into 22.7 liter, which will nearly be equal to 11.4 liter. So it means option B ke liye option 4 is correct. B equals to 4. Fine. Both the things are done. Let's see the third option. 1 mole of N2. Now we are already done with second and fourth. Only first and second are left, which is weight, right? So now we are given with the mole. We have to calculate the weight. So let's calculate the weight. So 1 mole of N2. What is the molar mass? The molar mass of N2 is 28 gram, right? So 1 means equal to gram given divided by 28 grams. So what is the grams? 28 gram only. So what is the option? 28 gram first, right? So then I write C equals to 1. Clear? The last option, it's already obvious that the option is 3, but let's see also. So 1 mole of SO2 is equal to how much grams? 32 plus 32, 64 grams, right? 0.5 mole will be equal to 32 grams, right? And that is what given in option number 3. So for D, it's option number 3. Fine. This is how we are supposed to do such type of questions. I know I have shown you the longest way of doing it. You can directly calculate it easily. Like, you know, the 16 gram is given. 16 gram is what? Same 1 mole. 1 mole is what? We have to find out the weight is already given. So it will not be the weight. It will be either volume or the second option. Now, volume is not equal to the 1 mole. Obviously, second option is the correct answer. Okay. So by doing such things, you can automatically find out your answers. Clear? Next, one more question. Let's do it. Okay. So we are given with 7.5 gram of a gas occupy 5.6 liter of volume at STP. The gas is. Okay. So what we are given with the volume, we are given with the gram. We have to find out what type of gas it is, right? So what we can do, we know each gas has specific molecular weight, right? For example, NO, the molecular weight is 16 plus 14, 30. N2O. N2O is 16 plus 28, 44. For CO, it is 16 plus 28. And then CO2 is also 12 plus 32, 44. Right? So obviously B and D are not the correct options. Either A or C are the correct options, because this is the only way to find out which gas it is. Okay. Now let's see. We know 1 mole of gas occupies how much? 22.7 liters, right? We are given with 5.6. So 1 liter will occupy how much? Will be occupied how many moles? 1 divided by 22.7 moles. And 5.6 liter will be equal to 5.6 divided by 22.7, which is nearly equal to 4 times. So the number of moles given is 0.25 moles. Okay. Now this 0.25 mole weighs how much? 7.5 gram. 1 mole weighs how much? 7.5 divided by 0.25. It means 7.5 multiplied 4, which is 30 gram. Right? It means, what is molar mass? Molar mass is the mass occupied by any substance, mass occupied by 1 mole of any substance, right? So this is 1 mole. This is the mass occupied by it, which is 30 grams. It means the substance, the gas, which weighs 30 gram, which is the molecular weight is 30 gram, will be the correct answer. And the correct answer is option A. NO equals to 30 grams. Clear? Is it clear? These are the, not difficult ones, but interesting type of questions based on whatever we have done so far. Okay. Now, next, we are going to talk about a very small topic, which is average molecular mass. What is average molecular mass? For example, there is a container and there are 3 types of gases present: A, B, C, and D. 4 types of gases are present, right? So the number of moles of A is Na and molecular mass is Ma. Same for B. Okay. Now what we have asked for, M average. What is the molecular weight, average molecular mass of this mixture? So what we can do is we can multiply Na, what is the mole fraction, into molecular weight. Sorry, not mole fraction, number of moles, plus NB into MB plus NC into MC plus ND into MD. Okay, divided by Na plus Nb plus Nc plus Nd. Means what? We have calculated the average of all the individual molecular masses multiplied with its number of moles with respect to the total moles present in the specific mixture. Okay, this is called as average molecular mass, which we find out when there is a mixture of gases given and we need to calculate the average of overall given. Okay, for example, let's do a question. Calculate the average molecular mass of a mixture of gases A, 3 moles of CO2, B, 1.5 moles of O2, C, 4 moles of N2, and D, 2.5 moles of H2. Okay, this is given to us. Now, what we are supposed to do, we are supposed to find M average. Fine. Let's calculate first MA. A is CO2. CO2, the molecular mass is 44 grams. MB, O2 is 32 grams. MC, N2 is 28 grams. And MD, it's 2 grams. Okay. Now we know the N, we know NA, NB, NC, ND. We know MA, MB, MC, MD. Now what we can do, we can directly put these values in the given formula. So M average equals to 3 multiply 44 plus 1.5 multiply 32 plus 4 multiply 28 plus 2.5 multiply 2, right? Divided by 3 plus 1.5 plus 4 plus 2.5. Okay, let's do the calculation. 12, 132 plus 32 plus 16, 48 plus 8, 2, 3, 112 plus 5 divided by 2.5 plus 1.5 is 4, 4 plus 4, 8 plus 3, 11. 10, 17, 2 plus 4, 6, 9. Once again, 10, 17, 1, 2 plus 4. 2 plus 4 is 6, plus 3, 9. No carry forward, 2 or 1, 11. So it will be somewhere 227 grams. So this is the average molecular weight of the given mixture of gases. Make sure these gases are non-reactive to each other. They are not reacting with each other. Okay. Is it clear? Now, whatever we have done so far, let's apply it to the chemical reactions. Okay. So application of mole concept on chemical reactions or chemical equations. Okay. Let's take an example of an equation. N2 plus H2 forms NH3. This is a chemical reaction which tells about the formation of ammonia using nitrogen and hydrogen. Right? Now, any chemical reaction, when we have the first step, even before solving the question, even before reading the question, is balancing the chemical equation. How do we balance? What one type of atom present on the left side should be equal to the other type of same type of atom present on the right hand side. Okay. So left side we have 2 nitrogen atoms. Here we have 1. Let's multiply it with 2. Now because it is written in front of NH3, hydrogen will become 6. 6 this side, will multiply it with 3. Okay. So this 1, 3 and 2 are called as 1, 3 and 2 are called as stoichiometric coefficients. What are they called? They are called as stoichiometric coefficient. And not just the coefficient, there is a significance of them present there. What is the significance? So this 1, 3 and 2 represents what? 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia, right? Means whenever there is a 1 mole of nitrogen present, it will react with 3 moles of hydrogen to form 2 moles of ammonia. Okay, this is the significance of these stoichiometric coefficients. Clear? Let's do a question, a very simple question on this. Calculate the number of moles of hydrogen required to form 4 moles of ammonia. Okay. Now, let's see what is the flow here. We are given with moles of ammonia, right? What we are supposed to do, we are supposed to find out moles of hydrogen. What do we know from the reaction? We know 2 moles of ammonia requires 3 moles of hydrogen. We know. Then 1 mole of ammonia will require 3 by 2 moles of hydrogen, right? And how many moles are given? 4 moles of ammonia. So 4 moles of ammonia will require 3 by 2 multiply 4, which is 6 moles of hydrogen. Okay? Is it clear? Any doubt? This is the simplest form of the question that can be done using the mole concept on chemical equations. Let's see different types of questions. Same equation. Let me take the same equation. N2 plus 3H2 forms 2NH3. Question. Find out the grams of ammonia formed and hydrogen used if the grams of nitrogen present is 56 grams. Okay. Now, always go to the finding of the moles. That is should be the first step. Why? Because we have the relationship between the moles. 1 gram of nitrogen does not react with 3 gram of hydrogen, but 1 mole of nitrogen reacts with 3 moles of hydrogen, right? So the gram will not, gram is, there is no relationship. The relationship in the equation can be in the form of moles only, right? So our first step should be finding out the number of moles. So let's see what should be the sequence here. First, number of moles of nitrogen. This is should be the first step. Then relationship between the moles of nitrogen and hydrogen and nitrogen and NH3, right? Then moles of NH3 formed and H2 used, right? And what would be the last step? Grams of NH3 formed and H2 used, right? This is correct. Now let's find out. So the first step is finding the number of moles of N2. So moles of N2 is equal to 56 by 28, right? Which is equal to 2. So 2 moles of N2. Now if 2 moles of N2 is present, how many moles of NH3 is formed? 4 moles of NH3 is formed, राइट अगर 8 मोल नाइट्रोजन है तो 2 मोल अमोनिया बना रहा है तो 2 मोल नाइट्रोजन है तो कितने मोल्स अमोनिया बनेंगी 4 मोल राइट सेम वे 2 moles of N2 will react with 6 moles of H2, right? This step is also done. Next, this step is also done. Next, we know the moles. We can easily find out the grams. So the grams of ammonia formed equals to number of moles multiplied by molecular weight. which is equal to 4 multiply ammonia का 17. So 8 to 68 grams. Okay. Same way, gram of H2 used. How many moles? 6 moles multiplied 2, which will give you 12 grams. So the 12 grams of hydrogen will be used if 56 gram of nitrogen is present to form 68 grams of ammonia. Clear? Any doubt? No, right? Easy. Next type of question. Same equation. Find out the find out the grams of, sorry, find out the grams of nitrogen required to form 100 grams of ammonia. Okay. Again, let's write down the equation. N2 plus 3H2 forms 2NH3. Right? Now, in this case, what we are given? We are given with the mass of product. So, what should be our sequence? First, moles of ammonia. Then, relationship between ammonia and nitrogen. From there, moles of nitrogen. From there, grams of nitrogen. Fine. So, first is moles of ammonia. So, moles of ammonia will be equal to 100 grams divided by 17, right? Now relationship. So moles of, how many? 2 moles of ammonia requires 1 mole of nitrogen, right? So 1 mole of ammonia will require 1 by 2 mole of nitrogen. We have 100 by 17 will require 1 by 2, 100 by 17, which is 50 by 17 moles of nitrogen, right? We got the moles of nitrogen. Now it's grams of nitrogen. So grams of nitrogen is number of moles multiplied by molecular weight. So it's 50 by 17 multiply. What is the multiplier? 28. So it will become this much grams. We can do the calculation. Okay. Easy. Let's see when there is volume given. Okay. Let's see. Let's do that way. Let's state another equation now. Okay. This is the equation given. Now the first step is balancing the equation. 4 carbon are present here. Let's multiply it 4. Hydrogen is 2 here, but 10 here. So let's multiply it with 5. Right? Oxygen is 8 plus 13. So it's 13 by 2. Either this or what we can do, we will multiply everything with 2. So we'll get 2C4H10 plus 13O2 forms 8CO2 plus 10H2O. Okay. This is our balanced chemical equation. Fine. Now the question is, find out the volume of CO2 formed by reactant (32 grams of O2). Okay. Now What we are given? We are given with grams, right? We have to go to the volume. Again, grams and volume through moles. So what should be the sequence? Moles of O2, then relationship between O2 and CO2, then moles of CO2, and then volume of CO2, right? This should be the sequence. Now, what is the grams? 32 grams. So moles of O2 will be 32 divided by 32, which is 1 mole, right? Now, 13 moles of O2 forms 8 moles of CO2, right? Then 1 mole of O2 will form 8 by 13 moles of CO2, right? Now what we are given? We are given with 1 mole only. So this is the moles of CO2. Now we got this one, moles of CO2. Now volume of CO2 is equal to number of moles multiplied 22.7 liters. Why? If when only it is given at STP. Okay. So it is number of mole 18 by 8 by 13 multiplied 22.7 liters, which will be equal to 181.6 upon 13 liters. Okay. This is our answer. Let's do another type of question. Find out the volume of O2 required and grams of butane required to form 2.27 liters of CO2 at STP. Okay. Again, very simple question. See, these type of questions, the concept is same, just twist and turn. One thing will be given, other thing will be asked, other thing will be given, one thing will be asked. It's only those three formulas. You can twist and turn anyway to find out the answer. Okay. First, we are going to write down the chemical reaction. C4H10 plus O2 forms CO2 plus H2O. We balanced this just now, 8, 10, right? Yeah, this is the balanced chemical equation. Now, what we are given? We are given with the volume of CO2. Again, volume of CO2, so what we can calculate? Moles of CO2. This should be the first step of every type of question which is dealt with the number of mole concept, right? So, moles of CO2, then relationship between CO2 and O2 as well as CO2 and C4H10. From there, we can find out the moles of O2 and C4H10. From there, we can find out the volume of O2 and grams of butane. Right? First is moles of CO2. So moles of CO2 is equal to 2.27 divided by 22.7 liters, which is 0.1 mole. Right? Now, if it is 0.1 mole, 1 mole of CO2 requires, 8 moles of CO2 requires 13 moles of O2. 1 mole will require 13 by 8 moles of O2. 0.1 will require 1.3 divided by 8 moles of O2, right? Same way, 8 moles of CO2 requires 2 moles of butane. 1 will require 2 by 8, 0.1 will require 0.2 by 8 moles of C4H10, right? Now we got what? We got moles of individual O2 and C4H10. What we have to do, we have to just multiply it with the molecular mass to find out the grams and volume. To find out the grams. For volume, we have to multiply with the molecular volume. So, grams of C4H10 will be equal to number of moles multiplied by molecular weight. What are the number of moles? 0.2 divided by 8. What is the molecular weight here? 12 into 4, which is 8, 48 plus 10, 58, right? So 4, 29, 2, 1. So 1.45 grams. Okay. Same way, volume of O2 equals to number of moles multiply molar volume. Number of moles are 1.13 by 80 multiply 22.7. So you can do the maths to find out the final answer. Okay. This is how we can twist and turn around to do the different types of questions. We can also be given with the number of atoms or number of molecules of O2 present and find out the number of molecules of CO2 formed. Or if we are given with these many atoms, these many molecules of CO2 occupies this much amount of volume. Find out the molecular weight or find out the grams of O2 required for this much, right? So if we are given with the uh, volume, with the number of atoms, we can find out the molecular volume from there. We can find out the volume occupied, right? And from there, the number of moles. And from the number of moles, we can do again these type of relationship to find out whatever is required in the question. Is it clear? Any doubt? This was the very small, topic. Going ahead, we'll deal with the bigger topics like, sorry. Going ahead, we have different things like composition by mass, molarity, normality. Sorry, these topic we can deal in detail in the next video. I hope you understand whatever I have taught and you have liked it. And if you have liked it and understood it, please share it with your friends, with your relatives, so that it can reach to different students and they can clear their concepts. Okay. Please subscribe the channel and also like the video. Thank you.